So you can now factorise a quadratic, but how do you actually solve a quadratic equation? And for much of what we're going to do, we're going to use what's called the null factor law. And the null factor law says, if you have a product, A times B, that's equal to 0, then either A must be 0 or B must be 0. The only way to get 0 out of a product is if one, or maybe both, of the factors are 0. So, let me show you what I'm talking about. Suppose I start with this. X times x plus 4 equals 0. Well, if that's true, that's a product, x times x plus 4. So if that's 0, then either this is 0 or that's 0. So we write it. Therefore, x is 0 or x plus 4 equals 0. So x equals 0 is a solution to this equation. If x is 0, then this is equal to 0. But there's another solution. There's actually two solutions here. And in fact, there's two solutions to most quadratic equations. This is the other solution. This factor equals 0. And if x plus 4 equals 0, then x must be negative 4. So that's how we use the null factor theorem, the null factor law. I'm going to show you a whole lot more examples. Let's stay with some simple examples for starters. X squared minus 8x equals 0. So this one looks more like a quadratic. This one is a quadratic. If you expand those brackets, you will get an x squared plus 4x. It's like this. It's just that one's already factorised. If you get an equation like this, then you have to factorise it first. So here, I can't solve this easily without first factorising. But there is a common factor, x, leaving x minus 8. And now I can apply the null factor law. If this is 0, then either x is 0 or x minus 8 is 0. Therefore, x is 0 or x minus 8 is 0. Well, there's one solution, x being 0. Here's the other solution, x must be positive 8. And sometimes it might be written yet another different way. Let me show you another way. You might get an equation that looks like 3x squared equals 6x. Well, that's really just another version of this, because I can write it in what's called standard form, put all the terms on one side equal to 0. Subtract 6x from both sides. Now I can factorise x. Actually, I can take out a 3 as well. X minus 2 equals 0. Now this has really three factors, the 3, the x and the x minus 2. But the only way this can be 0 is if one of those factors is 0. 3 will never be 0. Therefore, either x is 0 or x minus 2 is 0. Well, here's one solution, and the other is x equals positive 2. Okay, that's when I had an x squared term and an x term. See, all of those have it. This one has it, it's just hidden. So what happens, need to find some more space for my page. What happens if instead I've got something like this? 2x squared equals 50. Actually, there's two ways to solve this. First, I'm going to solve it the same way I solved them up here. My camera lost focus there. I'll try to keep something you can look at. I'm going to solve it the same way I did up here first. So, 2x squared is 50. Put them all on one side. 2x squared minus 50 is 0. Well, if that's true, I can factorise this. 2 times x squared minus 25 is 0. And I can factorise this because it's a difference of squares. It's x plus 5, x minus 5. Now, if you can't recognise the pattern for difference of squares, well, the first thing I'm going to tell you is go and do some practice for difference of squares. But the second thing I'm going to tell you is you can do it the hard way. What multiplies to negative 25 but adds to 0? It must be plus 5 and minus 5. So you can do it the long way. Okay, if this is true, then at least one of these factors must be 0. 2 will never be 0. So x plus 5 is 0 or x minus 5 is 0. And if that's true, then x is negative 5 or x is positive 5. Now note about my setting out. You'll notice I write the or once and then I just continue to work vertically. I did the same thing up here. I wrote the word or once each time and just worked vertically from there. You can keep writing or in between, but you don't have to. Another thing to notice, the fact that it was x plus 5 results in an x negative 5 solution. And the fact that it's x minus 5 results in an x equals positive 5 solution. The sign changes to get the solution. There is another way to solve that exact question. It looks like this. 2x squared equals 50. Well, I can divide both sides by 2, which is achieving the same thing as this did. Now, if x squared is 25, then there are 2 possible solutions. Be careful. You might say it's the square root of 25, but actually it could also be the negative answer, because the negative one squared will still give you a positive answer. So x is plus or minus 5. And you'll see that's actually exactly the same as what I've got here. This equation is quadratic. It has 2 solutions, positive or negative 5. You can solve it either way. Either factorise or recognise the square root, but remember it could be positive or negative. Let me show you another one that's like that, but that doesn't have a whole number solution. So let's suppose I have x squared minus 15 equals 0. So if x squared minus 15 is 0, I want to factorise this. Now this isn't what we would normally call a perfect square, but I can still write its square root exactly by writing root 15. And I've used surds to factorise it. Okay, if that's equal to 0, then either x is negative root 15. Oh, I shouldn't skip a step. I'll confuse you. Let me write all the steps. X plus root 15 is 0, or x minus root 15 is 0. Either this term is 0 or that term is 0. And that means, what I tried to do a minute ago, x is minus root 15 or x is positive root 15. And to show you what that looks like the other way, x squared minus 15 is 0, which means x squared is 15, which means x is plus or minus root 15. And there's no simpler way to write that. It's a surd. I can't write it any simpler than that.